Alright guys, after the video that I posted before about doing the in-flight adjustment of parameters, a friend of mine asked me if I could do a video on macrocells, right? Apparently the macrocells seem to be some kind of a mystery for a lot of people. So I have the radio here with this servo connected to the ESC, okay, of a Neo. And what I'm going to do now is, right now what I have it as is
bank 2,
bank 2,
bank
bank
3,
3, whatever.
bank 1,
right? And so I have it as
motor on,
here, motor on.
bank 2,
See,
bank
there's
3,
three
bank 2, bank
locations,
1, bank 2,
right?
bank 3, bank 1.
Okay, and that is because in here, in the flight parameters, okay, if you go to the governor, you have the 40, 50, and 60, right? So if we go and say bank 3, right, and we look at this, right, and I go select this number here, I can go up and down, as you can see here. See the servo moving? So that's what it's doing. It's simply copying the value here, you know, on each one of those. So if I go to bank 2, it'll go to 50,
bank 2,
and bank 1.
Bank 1.
Now, what happens if I want to do progressive throttle, like in a nitro, right? So what the way you do that is simply you are going to redefine what the ESC that's connected to the ESC output, which is also a throttle for a nitro, will redefine what the ESC channel does. So that's pretty easy to do with these macrocells, right? So macrocells is just another, you know, fancy way to call fancy mixers, you know, mixers and stuff like that. So here you have channel 1, 2, 3, whatever, yeah. So all of the cyclic channels, and you have the tail, auxiliaries, blah blah blah, and then you have here on number 10 ESC, which is the one that is connected to this thing, right? If you take a look at the ESC right now, if you take a look at it, it says it's simply an original channel. Okay, so let's just start by showing you how this works, right? Instead of the original channel, we're gonna say, let's make it into a curve, right? A curve is you know, a regular curve, you know, like that. But we have yet to define, okay, so this is a curve, but where's it getting the input from? So in other words, see the thing is in the middle there, 50? That's because even if I move this thing up and down, nothing happens, because the input is not defined. So I'm going to assign this stick, it's called collective, right, to this input, so that this macrocell, in other words, the mixer knows where to get the info from. So I'm gonna go look for the collective. I'm sorry, no, collective. Collective, there you go. And now look at this, you know, see, it becomes a plain Jane throttle. It's that simple. You simply say, okay, what is it? It's a curve, and its collective is the one that is going to be the input, and I want to make it into that. So let's say we use, let's leave collective there and select something else. Let's say we use a 3 level, right? So we're going to have as the input, let's go again, do the input collective, okay? And now look at what happens. Because it's at 3 levels, kind of a 0, middle, full. See? Simply by going there, it will know what to do. See that? That's it. All right. Just because I selected a 3 level, you can select all kind of stuff. You know, let's try an oscillator. See what's happened? Look at that, by itself, because it's oscillating. This is why they call it macrocells, because it has more powerful things than a regular mixer. You know, it can do this kind of fancy stuff. but it's pretty much it's just simply a mixer with a lot of fancy stuff in there. And let's call this is an interesting one. The channel is simply a channel that you define. This is an important one, because now if we assign again the input of this channel to be collective, right? Now we have a collective, right? Copy, perfect. But it has some nice features here, which is you have a limiter, maximum, and minimum, things like that. Why? Because if it's a throttle, right? A throttle channel, we're gonna have a maximum amount that we want to adjust. So let's say we have it at full, and we adjust the limiting throw. I think it's low throw. Let me see for a second. That would be throw maximum. Yeah, there you go. So by doing that, no matter what I do, the servo will not pass that. And if you look at the help here, we'll see limit max. The limit is an absolute limit that never will be exceeded, no matter what you do. The throw can be used to scale the throw to the given value. It is not a limit, so the whole throw is distributed by the given percentage. It's in other words a scaling, okay? So what I did here is actually a throw, so let me put it back at 100, and we're gonna use this one, which is the scale, right? So see how when I move it, that happens. So why is this important? Because in the case of throttle, right, you're gonna have the minimum, like the closed carburetor, right? So you might need to go, let's say here's your minimum, okay, and here's your maximum when you go full up, and then you make it your maximum of the physical, mechanical of the carburetor. Now you have a pretty cool channel that actually works from your actual limits, right? And then you go like, okay, so it's cool, I have it. Then you go, oh, I don't have a trim for that. This is where you get the important thing about macrocells, because macrocells are actually chainable. In other words, see what I selected here as input signal. I selected collective. You could actually select another cell to be the input. So in other words, if I use a cell that is doing something else, it can become the input of another cell. So what's cool about this thing is that you can actually add trim that we wanted, right? So instead of, so we're gonna go back again to this one. I'm gonna select this. Instead of that, we're gonna do a mixer. Mixer is exactly that, a mixer, you know? You have input 1, input 2, input 3, input 4. You can mix 4 things, right? So instead of saying, okay, I'm going to take the collective and use it for blah, 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 whatever, we're going to say, okay, we're going to take the macrocell, let's start with macrocell 30, and add macrocell 31. We have not defined it yet. Sorry, we have not defined them yet, okay? So, okay, now what happens? We have a mixer, and we move, nothing happens because macrocell 30 and 31 have not been defined, but this has already been defined as the mixer or the addition of these two. So, let's close this, and then let's go to macrocell 30. I use 30 just because it's easy to remember. Doesn't really matter which one you use. So I'm going to select this one, and I'm going to add to this one, I'm going to do the same channel thing that we did before, right? So we have the input signal is the collective, okay? And the input signal limit is not fill safe off, okay. Change rate, and obviously we can do the limits like before. Let's just say minus 90, just to have a limit here, another here, another, 90. So it goes, instead of going from minus 100 to plus 100, it goes to that. Sorry. Now you can see that when I move the stick, is doing that. See? The one and the other one, okay? So, okay, we have this is defined. We can actually call it, let's say, throttle. Okay? Throttle, enter. So we know that this function is going to be throttle, and it's the cell number 30, microcell number 30. Okay, so let's go to the next one. So this is pretty cool. So the next one is going to be, let me see what could be this one. It's actually, you could call it could make it out of a channel to have all these features to adjust the trim. So let's call it a channel. But now we're gonna have as an input trim. I think this is the 1 and the 2, probably 2 in this one. The input will be that one, okay? Let's see which one that is. Okay, so this one is 2. So it's trim number 1. Trim number 1. Okay, so let's see. There you go. So that's the trim that I want. So I want this to be the trim for the throttle, okay? And now the maximum and minimums, let's make this 10. Let's say 20, just to have a little bit more. And let's make this one 0. Okay. And the throws, same thing. Let's make throws 0 minimum and 20 max, okay? All right, so now we have result when it's full forward 20, when it's here 0. So actually, this actually works better if we have plus 10, minus 10, apparently. No, actually, no, that's good. Direction center, the center is going to be, I think the center is supposed to be minus 10, I think. Let me see if this one would work. So 20, no, actually no. Let's just leave this at 0. We can explore that later. Let's not complicate things. Right, so we have the fail safe, change rate, okay, trim 1, perfect. So we got the minimum 0, maximum 20, like we wanted, okay? So let's go now. We have 30 and 31 are mixed like that, and now we have ESC, which is 10, the 30 and 31. Okay, so let me see. I might have hold on for a second. This is Selector, trigger, original, channel, fix, level, multiplex. I think it's multiplex, the one that we need. Selector. Yes, MC30. Oh, no, it's not multiplexer. It's actually a mixer. Okay, so MC 30 and MC 31. Okay. And oops. Okay, and this is the throw that we want on that one. How much we want that to be. Okay, so now we have from this one, from the MC30, we have the full amount. Okay, and now from the other one, which is this one, we're gonna add. Actually, we scaled it on that one, so I'm gonna use also 100%. Because that's already scaled to 20. Okay, so we're gonna have that, and Now notice how we have now trim. See, we have trim now, which is pretty cool, right? And because we mixed MC30 and MC30 and MC31, and the MC30 was selected as a channel, and MC31 was selected as a channel also, I think. Yes, channel, but limited. So now let's do something, let's show you how we can change this also. So remember what I did, 31, I limited this, okay? So I'm going to actually go first to original, and I'm gonna go back again to channel, okay? And I'm going to use the signal, it's gonna be trim, I think it was trim 1, correct? Okay, so the reason why I'm doing that is because now we have apparently full movement, right, on this, but instead of mixing it, instead of doing it from the other one, we're gonna make it, we're gonna scale it to we're gonna scale it to the maximum that the other one allows in the same place. In other words, we are going to limit the total of the mixing that's coming from the trim, from this trim one, using the very first one, the actual ESC mixer that we use, okay? So here we have, so this one is going from, so let me show you here. This one's going from minus 100 to plus 100. Now what we want to have is from 0 to 100 because we don't want to go lower than the minimum. So over here we go, limit maximum, minimum, and maximum. And we are gonna use 0 here instead of minus whatever, right? Minus, okay. So, and so we have right now 0 to 100, as you can see. 0 to 100. Okay, now, because of that, we have now the two. This one is going to be the throttle. Oh, let's name it. Let's name this one the trim, so we remember which one is this one. Okay, trim. Oops. TRIM. Okay, so now we have throttle and trim on the 30 and the 30 and 31. And we go back again to the one that collects that information and makes it into this one, which is a ESC. Again, ESC is the standard, so we select that one. We also have a mixer, but we have it as MC31, MC30 and MC31. But this is where we make it less the amount of the additional. So we go 0, right? Okay, and now we have the trim. If you see that that's not enough, we simply come here and say, okay, how much do we need? We add a little bit more. Let's say, okay, let's say it's 20%, all right? Perfect, that's 20%. And now we have more movement for the trim, right? So in other words, we created our own channel doing what we want. So we're using the collective as input, the trim as input, into two 30 and 31, 30 and 31 macrocells. We define on the 30 macrocell that's going to be a collective and it's full movement. Actually, we made it limit minus 90 and plus 90 because we don't want this to go farther out than the physical limits. So that's why we have that here, which is pretty cool. And so sorry, the trim, we also selected that as a channel, but we defined the input as from the trim pod, which is this one, right? And based on that information, we also limited the trim to only send positive signals to the mixture, because we want it to be added to the minimum 0 plus whatever positive comes out of the trim. So we made that, and so these two here get combined into the stock one. By the way, these are the stock, all the channels. Channel 1 to 4 for the cyclics, tail, auxiliary, flaps, ESC. Okay, so this one is the one that you want to have as the final ESC output. So this is why here's where you add the mixer, where you add this to Macrocells that we just defined, and that's it. It's just that. It's not a you know rocket science or anything like that. It's simply a fancy way to call fancy mixers. Okay, so that's how you do that. So let's explore a little bit more. Sorry. So we had oscillators, original, channel, trigger. Okay, trigger. Let's use threshold, input signal. Again, let's use the collective because it has a positive and. So what we have here is a threshold. It's this thing, right? At a certain spot, it triggers and it goes full. So when we see that, we can see that this happens, right? See, at this point, and then switches. So it's simply a trigger. You can select which way you want to do that. If you want to go positive on the lower button and negative on the top, or the other way around. Okay, the threshold is where it happens, right? If we make it, let's say, negative 50, all right, so this is what happens. Instead of triggering here in the middle, you're going to start triggering lower, see, because that's where the minus 50 is. So 0, minus 50, 0, I'm sorry, minus 100, minus 50, see the trigger, minus 50 and 0, plus 50 and 100. So you can select where you do that switch. So normally it's supposed to be in the middle. Where's that at? Here. Okay, 0. And that's that. Okay, so I'm using this channel to show you different things. This is fixed. It's simply on bank. Use bank 1, 2, 3, 1 to 4, and then you go, okay, bank 1 and 2, 3 and 4, and go, let's say this here, and fix. Use bank. Okay.
Bank 1, bank 2,
bank 1
bank
and
1,
bank 2. See?
bank 2, bank
It
1,
changes. So
bank
if we
2,
go to the output, the result here, we'll see
bank 1,
how it changes.
bank 2,
Because
bank 1,
I made it
bank
into
2.
a minus 40 on bank 1. Okay. All right. So next one, let's say fixed. Then you have 3 level. We already saw that. You know, multiplex. Multiplex is pretty cool because it allows you to select different things from different input levels, right? So in other words, you can make it like in this section here, the input of this channel, the lower, comes from some macrocell that you decided. Then as it passes to the middle, then it switches to another macrocell or another thing, okay? And so we can actually show how that works. Let's assign these things to actual trims, right? So let's use trim 1. This is going to be trim 2. And we're going to call this one here pot 2. Okay, so we're going to have this one here, and this one here as the inputs. So selector will be again, we're going to use again the collective, so that when it's here, it uses trim 1. When it's here, it uses trim 2. And when it's here, it uses pot 2 as the input. So if I have it here, right, look at what happens. I change the pot 2, which is defined as the input, right? But the moment I start moving this thing, it goes to a different one. So now it's listening to trim 2, which is this one. See how it listens to that one? But if I go to the top, it listens to this one. Okay? So if I go to the bottom, then it's going to be this one. See? So it pays attention to that one. So that's what the selector is. So this, I'm using trims and things like that to make it easy for you to visualize it. But they can actually be the result of a macrocell like we did before, like the one that we did for the throttle and the trim. Okay, so that's pretty cool there. So let me go and get another one. Multiplex, and now let's see. 3 level we did, fix we did, fix we did, trigger we did, oscillator. Well, the oscillator is simply that. Oscillates, and you simply select when, how fast, and all the things, you know. Period, amplitude. So the period could be smaller or faster. See? So if you have, let's say, a radar that you want it to look like that, you know, a scale radar, and you want it to look like the radar is scanning the skies, you know, there you go. That's what this thing is for. All right, so oscillators are curve. We already saw it, right? So you can use this for something like this, for instance. Let's say a 33 stops. Okay, and let's 33, 30, yeah, something like that. So we go, and we have now, input collective. Again, you can just use that. And now notice how it will be limited here because I made it. Let me I made this here. So if I change this one, right, you'll notice immediately how it changes. See, to whatever I put it. I put it 120, and that's why it's so far. But notice how it will go and follow as I go. As soon as I go 120, it's gonna go fast to 120. So it's obviously something that you can use for variable response using a curve assigned to this as the input of that. Okay, so that's what the curve is. Mixer very, very hard. That's what we used before to mix and the channel. I already explained that, and the original, which is this one here, is gonna be the one
Bank 3
that we
Bank
have
2
as
Bank
original.
1
So that's it.
Bank 3
That's the whole.
Bank 2.
That's the whole macrocell, you know, mystery or whatever. It's super simple actually. So there's just simply a different way to call mixers because they're better than mixers. And another thing that is interesting is that, from what I understand, the macrocells are actually compiled and then uploaded into the firmware. So there is an advantage on that because instead of having to have a program that decrypts the mixing and adjusts with programming and to do what you want, this is actually compiled right now, sent to the Neo, and it becomes part of the firmware. So all of these movements are actually as if it was programmed originally like that on the firmware. So it makes it extremely fast, and that is one of the it's really an incredible feature of these V-Touch radios. I am not sure, and it's probably yes, it also applies to the regular V-Control, but I do know that no other radio has that feature in the world, and that's something that is only from the V-Controls. So that's it. That's the whole macrocell mystery, and hope you guys liked it. And now you guys gonna start enjoying and using the macrocells, and you're not gonna be limited to what you can do. You can do whatever you want, and it's not a mystery. It's just simple, like you saw. It's very simple stuff. And another thing that I forgot to tell you is that you can actually chain link several, not only like we did only from one to the next, but you could actually go from one to the next to another one to another one, and then another branch coming from another side, mix them together, and you can pretty much create anything. That is why it's different. That's the one thing that it makes it not a regular mixer, but that's why they had to call it macrocells, because they are macros. You know, if you know programming, you know that macros are that. You know, that you define what the macro does, and then you can put them, you know, in sequences and chain link them and things like that. So that's it. All right. Have a good one. Bye-bye.